Okay, we're going to find the vertical asymptotes on this function. So I would suggest you first write the reciprocal identity for secant. So secant is equivalent to 1 over the cosine of pi x over 2. And where this is equal to 0 or undefined is where the vertical asymptotes will occur. So the vertical asymptotes will occur when cosine pi x over 2 is equal to 0. So that's what we're going to solve for. Now remember, the last thing you do is take into account whether the function has been sped up or slowed down. You first want to just do the most basic version of the function, which is where does the cosine of x equal to 0. And if you recall from the unit circle, it's at the fractional pi's. Alright, so in standard position, starting at the first one, it would be pi over 2. And then you would add pi n to get to the next one, because you'd have to walk a distance of pi to get to the next one, and then you'd have to walk a distance of pi to get to the next one. So this is going to end up giving you all the coterminal angles of cosine x equals to 0. So it's really the very last step you take into account whether the function's been sped up or slowed down. So instead of this just being an x, this is actually a pi x over 2. So at the very end is when you counterbalance whether the angle's been sped up or slowed down. You could do this all at once. So if you multiply everybody by the reciprocal of this, or you could do it in two pieces, whatever you want. So the reciprocal of this is 2 over pi. So if you multiply everybody by 2 over pi, you'll just knock all that out at one shot. Alright, this is 2 over pi. So when you cross this out, this is going to leave you with a 1. It's not like it's a 0, okay? Because it's the same thing over the same thing. And then the pi's will cancel here, and you're left with a 2n, where n is an integer. Alright, so this is where all the vertical asymptotes will occur. So they will occur, like if n is 0, it'll occur at x is 1, right? If n is 0, then at x is 1. If n is 1, then at x is 3, right? So this function here will generate all the x values, which then get plugged into the function, which is where the VA is occurring. Okay, it's that kind of idea. There's an infinite amount of VAs, so this function generates that infinite amount of VAs since it's impossible to list an infinite amount of items. Alright gang, that's it on this one. I'll catch you. Bye.